The overload and collapse of a roof or floor structure can have tragic and costly consequences. Open web steel joists are manufactured truss assemblies. Often used in combination with metal decking, steel joists distribute roof and floor loads to supporting walls or girders. Now building owners and developers can add a margin of safety to the structural design of their facilities. FlexJoist introduces several new building ownership advantages, including the activation of on-site emergency management and the possible prevention of a collapse. In the event of an overload, the FlexJoist system introduces the advantages of ductile tensile yielding and time delay to the design of steel joist-supported roof or floor. FlexJoist system design is fundamentally different from traditional standard joist design, including cold-form steel channels, Z-purlins, and wood joists, as well as open web steel joists. To begin with, FlexJoist design deliberately varies the relative strength ratios of a joist component members. This is to establish a primary limit state, whereby ductile tensile yielding enables FlexJoist to gradually deform during an overload condition. Under load test conditions, a FlexJoist bottom chord and end web will yield substantially during the primary limit state. This is because all other joist components are intentionally designed to be overstrength relative to these members. The FlexJoist continues to support loads in excess of the elastic limit while undergoing extreme deformations. Load sharing between adjacent joists is an inherent function of the FlexJoist system. Loads in excess of the joist plastic load capacity are transferred to adjacent joists, while the individual joist continues to sustain its plastic load capacity. During repeated load tests, FlexJoist exhibits a sustained primary limit state with a prolonged deflection prior to collapse. Extreme deflection in excess of the joist's elastic limit provides early visual warning of an overload condition. Even when the elastic load limit has been exceeded, the joist continues to support the load while undergoing extreme deflections. It is also uniquely characteristic of FlexJoist that a collapse occurs only after significant plastic deformation, during the secondary limit state of a buckled member. Compared to a standard design steel joist, the FlexJoist collapses after a significantly longer yield time with substantial deformation. In the building structure, the advantages of FlexJoist are immediately clear. Now building owners can have advanced notice of a potential structural collapse, gaining the vital time needed for emergency management. FlexJoist is ideally suited for electronic monitoring because the bottom chord and end webs will be highly stressed prior to collapse. An overload condition can alarm locally and remotely. This simple safety solution can function as a standalone management package or be integrated into existing building alarm systems. Informed of the location of an overload, management can also see the progression of the overload. The system can provide a measure of loading progression, allowing for decisions as to evacuation, roof shoring, and load removal. In this era of progressive building innovation, steel joist overload design is now a safe and practical business investment. For more information about FlexJoist, visit our website.